Hello friends, today I am going to solve LeetCode problem number 53, maximum subarray. So we are given an array of integer nums and we need to find the subarray which has the largest sum and return its sum. And the subarray must be contiguous. We also need to keep in mind that the values in the integer are both positive and negative values. So it's given here the values ranges from positive to negative, and the length is at least equals to 1. So how could we solve this problem? One way to approach this problem is by using brute force solutions. In the brute force solution, we start from the first element and then we calculate the sum so far. The sum so far is -2, right? And then the maximum sum so far is also equals to -2, and then we add another value to that sum. So now the current sum is equals to 1, the max sum. Since the sum is greater than the max sum, we update our max sum, which is equals to -1. Then we add our next value. Now the sum becomes equals to -4, which is less than max sum, so we do not update this. We add a 4. Now the sum is equals to 0. We update our max sum to 0. Then we add a -1, the sum becomes equals to -1. We add a 2, the sum becomes equals to 1. So we update our max value, max sum, and then we add a 1 here, the sum is equals to 2. Now we update our max value to 2. We add a -5, now the sum is equals to -3. Then we add a 4, now the sum is equals to 1. So in this iteration, the maximum sum, the value of max sum is equals to 2. Now we perform next iteration where we are going to start from the second index. So this becomes our starting point. So the sum so far is 1. Then we add -3 to this, the sum becomes equals to -2. We add a 4, the sum is equals to 2 here. We add a -1, the sum is equals to now 1. We add 2, the sum becomes equals to 3. So now our maximum sum is equals to 3. We add a 1, the sum is equals to 4. We add a 5. Okay, we update our maximum sum to 4. We add -5, now the sum is equals to -1. We add a 4, the sum becomes equals to 3. So far the maximum sum is now equals to 4. So we do the same process again with starting from index -3 and then moving over all of the values. So when we start from -3, well, -3 plus 4 is equals to 1. 1 plus -1 is equals to 0. 0 plus 2 is equals to 2. 2 plus 1 is 3. 3 plus -5 is equals to -2 plus 4 is 2. So basically the max is still 4. Now when we start from 4, the max so far is 4, and 4 minus 1 is equals to -3. -3 plus 2 is 4 minus 1 is equals to 3. 3 plus 2 is equals to 5 here. So far until here our sum is equals to 5. So we update our max value to 5. Then we add 1 to 5, the sum is equals to 6. Now the max becomes equals to 6. We add a -5 to that, the sum is equals to -1. -1 plus 4, the sum is equals to 3. Then we start from this portion, start with this one. So -1 plus 2, 3, -1 plus 2, and so on. So basically we will at the end return this value. However, the time complexity for this one will be big O of n squared, because for each of these indices, for each of the values here, so for each of these values, each of these indices, we are passing through all of the values in the arrays. For these we are again iterating over all of these. For these we are iterating over all of these, so the time complexity becomes O of n squared. So how could we optimize this solution here? One way to optimize this solution is to identify the fact that we are looking for a maximum value, and the maximum value, when we add two values a and b, the maximum value will only result when we are adding positive values. So both of them should be positive values, but if both of them are positive, that is only when we the sum will increase. If we add a negative value, any one of them is negative, the sum will actually decrease, right? So that is what we need to keep in mind while solving our problem next. So what are we gonna do is we start from -2. So far the current sum is equals to -2, and then our maximum value is also equals to -2 here. We add a 1 here. Now we know the value, this value, let it be a, and this value be b. A is negative, and we know negative value will reduce the whole sum, right? If we add a plus b, the sum will reduce, so we are just going to ignore this value, and then our sum is only equals to 1. So the current sum is equals to 1, the maximum sum is also equals to 1 because it's the max so far. Now this becomes our we move on to the next element here. This is b, this becomes our a here, and now we know that we adding a negative value will definitely reduce the value. However, we need it to be contiguous. So far we have value 1, and then we are adding -3, which results in the value to be -2 here. So we just keep the sum because we might encounter other values here, or so actually we are just going to ignore this. So we ignore every element so far because the sum is equals to negative here. This value becomes negative, and then adding negative to any other value will reduce our sum, right? So we ignore that value, the sum is equals to -2. Of course we add it to us, we calculate the sum, which is -2, and then we ignore this value. Now we start from 4. The current sum is equals to 4, so the sum is equals to 4, and then we add -1 here. When we add -1, of course our value is decreasing, right? But we also need to keep in mind that there might be some positive value that would actually increase the whole value of the sub array. That is because if we ignore this -1, we also need to ignore this -4 because the sum needs to be contiguous. So in order for us to keep this -4 value, we also need to keep this -1. So we are gonna keep this whole sum until this point, which is equals to 3. The maximum so far is equals to 4, and then we add a 2 here. The sum is equals to 5, then the maximum so far becomes equals to 5. We add a 1, the sum is 6, and the max is also equals to 6 here. Now we add a -5 here, and now we know adding -5 is reducing the value, right? So it's contributing, it's to decrease the value to 1. But still we keep that value because we don't want to lose this thing, but we have already reached our maximum value here. So let's just keep moving, and we add a 4 to this value, so the sum is equals to 5 here, but our maximum, we have already found our maximum, which is equals to 6. So this becomes the value that we want, so we return this value. Now let us code this problem. Talking about the time complexity, since we are only performing the iteration only once. It is O of n time complexity. Now let's code this, code the solution. So we need to start from the first. We need to keep track of the current sum, and we need to evaluate the maximum value every single point of time. So for let current sum, since we are starting from the first value, it will always, the current sum will be the value of that, and the max sum is equals to the first value, which is current sum. And then we start from I equals to 1, I is less than nums length of the array, and then increment I. And if current sum is less than 0, we are gonna update our current sum, and current sum plus equals to nums I, and then max sum equals to mat dot max of max sum or current sum. So what we did here is we are removing the negative values. So if any of the values here previously encountered was negative, we just ignore this value. We are ignoring this -2 here when we encountered 1. Okay, let me just refresh this whole thing, erase this whole thing. Okay, so we are actually ignoring this -2 when we are adding 1 to the value. So the current sum is 1, and we update the max sum. Again, we added a 3, and now our prefix was, the sum so far was -2 current sum, and since -2 plus 4, the negative value will not contribute to the maximum sum, so we ignored that, and we actually reinitialize the current sum and add a 4 to that value, and then update our maximum value. And at the end, we are gonna return our max sum here. Now let's run our code. Okay, great. So the time complexity here is O of n, and the space complexity is O of 1, because we are not using any extra spaces here.